Hi, my name is Joshua Reibert and I'm going to present the paper Multitouch Interaction with Parallel Coordinates on Large Vertical Displays, which is the result of a research collaboration between the German Aerospace Center in Jena and the Bauhaus-Universität Weimar. Large high-resolution displays, also abbreviated as LHRDs, are human-scale environments that offer an increased screen real estate that information visualization has yet to take advantage of. Especially parallel coordinates benefit as a larger screen space and resolution allow the visualization of more attributes, improve the legibility of individual items, and reduce clutter to reveal patterns in the data. Working with parallel coordinates, users usually stand back for an overview and then approach an axis or a pair of axes to analyze distributions or correlations, which creates a kind of natural focus and context. Multitouch interaction is well suited in supporting users to work with the data from up close, but at wall-sized displays it comes with new challenges, such as uncomfortable long-range touches, possibly across a whole screen, and limited physical reach, resulting in uncomfortable crouching for the lower screen areas and no access at all to the upper areas for most users. We developed a multi-touch vocabulary in an iterative design process to overcome these limitations and to enable users to interact with parallel coordinates on LHRDs even beyond arm's reach. The gestures are mainly bimanual and make use of the concept of hold and move to fixate the background with a non-dominant hand and then manipulate an object with a dominant hand. Users can vertically shift axes by holding the background and subsequently dragging the axis. While this will partially move the axis off-screen, it brings a region of interest at full resolution into a convenient vertical position for interaction. To complement physical navigation, a horizontal fling gesture triggers a cyclic horizontal scrolling of the axis. The strength of the fling controls the amount of scrolling, and axes that are shifted off-screen reappear on the opposite side in a seamless transition. A background hold and a subsequent horizontal drag moves a single axis. To avoid long-range dragging, the axis moves directly with the finger at first, but the distance is amplified with a hyperbolical mapping after a threshold, and thereby extends a user's reach across a whole display. A two-handed pinch gesture brushes a value range on an axis to select all items in that range. However, even on a high-resolution display, clutter and overplotting are an issue. A hold and a subsequent drag on an axis ties the value range to the fingers and creates a focus area, whereas the context to either side is compressed. Both the creation of focus areas as well as brushing rely on two-handed gestures for defining a value range on a vertical axis. Since the axis vertical extent exceeds a user's reach, a desired selection is sometimes not possible directly on the axis, but this may only become evident during the interaction. As a consequence, we propose a vertical range extension that fluently extends the range using the horizontal distance from the axis using the same hyperbolic transfer function as before. It works similarly for defining focus areas. Due to contact restrictions, we did not perform a formal user study, but instead invited 4 experts to review and evaluate our system and to find potential usability issues. Our participants used our system with a movie dataset after a tutorial and a free exploration phase to solve 5 tasks with the Think Aloud method to comment on their interactions. All participants were able to use our system and the multi-touch gestures to successfully solve each task with the dataset. They stated that the interaction vocabulary was suitable to solve such tasks and comprehensively supported them in their visual analysis. Our participants especially liked the vertical shifting of axes, the long-range horizontal axis dragging, as well as the vertical range extensions for brushing and focus areas. Yet, they preferred direct interaction whenever possible and navigated physically instead of using the cyclic scrolling since physical navigation does not change the position and order of axes. Furthermore, they uncovered a lack of distinction between the gestures for brushing and the focus areas. In contrast to previous works, our multi-touch gesture set facilitates interaction from up close and yet equips users with the means to reach the whole screen. Our study shows that participants prefer direct interaction when possible, but on such a display that is not always the case, and they appreciated our range extensions, which allowed them to fluently extend the vertical range beyond their physical reach. Hold and Move was originally proposed for mobile devices, but we have shown that it works well on LHRDs and helps to distinguish the target of a manipulation. We believe that mid-air gestures or speech input are well suited to supplement our gesture set with the means of interaction from a distance, to work at a personally favored distance, or even take turns of using remote and close-up interaction. This concludes my talk. Thank you very much for your attention.